In this video, we will study about the complement system. We will talk about the overview, the various activation pathways involved, and the various immune effects of the complement system. The complement system is a group of about 20 plasma proteins that form essential part in the innate immunity. The word complement is used because the complement system enhances or complements our immunity. The complement system proteins are mainly synthesized in the liver and then widely distributed among the body tissues and the fluids. The complement system comes into effect only when it is activated. Out of the 20 plasma proteins of the complement system, 11 proteins are mostly involved, named as B, C1 to C9 and D. These are mainly enzyme precursor and they catalyze a series of enzymatic reactions that form the final products of the complement system that have various immune effects. Now let's look at how the complement system is activated. The first is the complement activation resulting due to the antibody-antigen reaction, which is known as the classical pathway. The second is through the bacterial endotoxin, which is known as the alternative pathway. And the third is the lectin pathway that results due to the protein known as mannose-binding lectin. Now let's study in a bit detail about the classical pathway. The main trigger of the classical pathway is the interaction between the antibodies and antigen. This reaction activates the C1 component of the complement system. The C1 component then cleaves C4 component into a smaller component C4a and a larger component C4b. The C1 combines with C4b and forms C14b. This is an enzyme which converts C2 into a C2a and C2b. These two components combine and form the C14b2a. This is an enzyme known as a C3 convertase. The C3 convertase then splits C3 into C3a and C3b. The C3b combines with the C3 convertase and forms C14b, 2a, 3b. This is also an enzyme known as the C5 convertase. The C5 convertase similarly converts C5 into C5a and C5b, out of which C5b is the larger product and combines with C6, 7, 8 and 9 to form C5b, 6, 7, 8, 9, which is the membrane attack complex. In this cascade, you can see some components like C5a and C3a which do not have any use. They have other immune effects which we will discuss later. Alternative pathway of the activation of the complement system. As we all just studied, the antibody-antigen reaction is the main trigger for the activation of the classical pathway. But the alternative pathway is mainly triggered by the bacterial endotoxin. The bacterial endotoxin is a lipopolysaccharide compound which is found in the outer membrane of the gram-negative bacteria. The other triggers of the alternative pathway are the yeast cell wall and the cobra venom factor. The first step is the spontaneous hydrolysis of factor C3, which is present in our blood plasma. This hydrolysis is a spontaneous process where the factor C3 is converted to factor C3b. This allows the attachment of the factor B to the factor C3b and opens the active site on factor B. The factor D, which is another complement enzyme, then splits factor B into subcomponents factor BA and factor BB. The factor BB then combines with C3b and forms the C3 convertase of the alternative pathway. This may have a different complement structure but has similar function of converting C3 into subcomponents C3A and C3B. The rest of the steps are similar to that of the classical pathway, that is the formation of C5 convertase and subsequently the formation of membrane attack complex, which has a complement formula C5B6789. Now, let's talk about the lectin-mannose pathway for the activation of the complement system. The lectin-mannose pathway depends upon the protein known as mannose-binding lectin or the MBL, which is synthesized in the liver. Now, organisms like Neisseria, Candida and Salmonella have glucose and mannose residues in their cell wall. Whenever these organisms enter the human body, the protein mannose-binding lectin recognizes this and activates a protease called the MASP, or the mannose-binding lectin-associated serine protease. The MASP is a protease which binds mannose-binding lectin. The MASP then triggers the activation of components C4 and C2 into their subcomponents C4A and C4B, and similarly C2 into C2A and C2B. The factors C4B and C2A combine to form the C3 convertase of the lectin pathway. This C3 convertase has a similar function as described earlier, and then the pathway proceeds further as described earlier. Let's talk about the immune effects of the various complement products. The first is the opsonization. The factor C3b strongly activates the neutrophils and macrophages. These activated neutrophils and macrophages then engulf the foreign microorganisms known as phagocytosis. The second immune effect is the cell lysis. The membrane attack complex, the C5B6789, has an effect of rupture of the bacterial cell wall, which destroys large amount of bacterial load. The third effect is chemotaxis, where factor C5a attracts the neutrophils and macrophages to the area where the antigen is present. Another complement effect is the activation of the mast cells. The factors C3a, C4a and C5a have a direct effect of activation of the mast cells and the basophils. This causes the release of large amount of mediators of inflammation like histamine and serotonin, which potentiate the immune response. So this was all about the complement pathway. Thank you so much for watching this video.